This lesson is to go through the division properties of exponents. When we have a quotient of powers with the same base, what we are going to do is we are going to subtract the exponents from each other, and let me show you why that works. If we had x to the third divided by x squared, if we expanded this out, this would be x times x times x divided by x times x. When you simplify this here, x divided by x is 1, x divided by x is 1, and you're left with x to the first power. So essentially, we can take our exponent 3, subtract it from the denominator exponent of 2, and we can get the new exponent of 1. In this example, we have x to the third divided by x to the first power. This is x to the 3 minus 1 power. We also have y to the fifth power divided by y to the second power, y to the 5 minus 2 power, and as we simplify, we get x squared y to the third power. When we have an entire quotient or a fraction to a single power in parentheses, we can take the numerator to that power and the denominator also to that power. For example, if we look at this right here, 4x to the third, so we can say 4x to the third is raised to the second power, as well as 5 is raised to the second power. From here, we know that 4 to the second power is 16. And then x to the third power to the second power, the rule here is we're multiplying. This is going to be x to the sixth power divided by 5 to the second power, which is 25. Here is some practice to try on your own. In this case, 4 to the fifth divided by 4 to the second is 4 to the 5 minus 2 power, which is 4 to the third power, which is 64. X to the sixth divided by x to the fourth is x to the 6 minus 4, which is x squared. G to the fifth, h to the fourth divided by g squared h. We have g to the 5 minus 2 power, h to the 4 minus, this is a 1 power, which gives us g to the third, h to the third. Z to the second divided by z, which is z to the first power, z to the 2 minus 1 is z to the first power, or you can just write it as z. X to the fifth, y to the third divided by x to the fifth, y squared. This is x to the 5 minus 5, y to the 3 minus 2. 5 minus 5 is x to the 0 power, which we are going to learn shortly that this is 1. Y to the first power, so all we're left with here is y. In the next practice problem, negative 3/15 simplifies to negative 1 over 5. So that is a 1 in the numerator, a 5 in the denominator. M to the 7th divided by m to the 4th ends up being m to the 3rd. R s to the 6th divided by r to the 4th s. This is r to the 1 minus 4, which is r to the negative 3rd power, s to the 6 minus 1, which is s to the 5th power. In this example, x to the 8 minus 4, y to the 9 minus 6, and z to the 2 minus 3 gives us x to the 4th, y to the 3rd, z to the negative 1st. The first thing we're going to do here is simplify the parentheses. We have our 3, x squared divided by x is x, y divided by y is 1. So we have 3x to the 4th power, 3 to the 4th power is 81, x to the 4th power is x to the 4th. First thing we do is simplify in parentheses. 5 over 2 can't be simplified. M to the 4th divided by m squared is m squared. N to the 5th divided by n to the 1st power is n to the 4th. 5 over 2 to the 3rd power is 125 in the numerator, 8 in the denominator. M squared to the 3rd power is m to the 6th. N to the 4th to the 3rd power is n to the 12th. Simplifying in the parentheses, negative 3 over 2 can't be simplified. B to the 6th divided by b to the 5th is b to the 1st power. C to the 3rd divided by c is c to the 2nd power. Negative 3 squared is 9. 2 squared is 4. B squared is b squared. C to the c squared squared is c to the 4th. Simplifying what's in parentheses, 5 comes down. G to the fourth divided by g to the fourth is 1. H to the first divided by h to the second is h to the negative first power. 5 to the everything to the fourth power. 5 to the fourth power is 625, not 24. And then we have h to the negative fourth power, because negative 1 times 4 is negative 4. Now we have a few more properties to talk about. The first one is the zero exponent. For any non-zero number a to the 0 power, it is always going to be 1. If we have x squared divided by x squared, anything divided by that same thing we know is 1. If we use our rules, x to the 2 minus 2, that gives me x to the 0 power. And that's how we know that anything to the 0 power is always 1. So we can talk about 5 to the 0 power. That is going to be 1. This fraction to the 0 power, which really should be up here, is going to be 1. Anything to the 0 power is 1. Now we're going to talk about negative exponents. Let's use this example right here. X squared divided by x to the fifth. Using the rule that we know that this is x to the negative third power. Another way to look at it, if we expand it out, in the numerator we have x times x. In the denominator we have x times x times x times x times x 5 times. When we go to simplify this, these two x's, they divide out to 1. These two x's divide out to 1. The only thing we're left in the numerator is 1, and on the bottom we have x to the third power. So we know that x to the negative 3 is 1 over x to the third power. We show this in the rule right here. Any base to the negative n power is the same thing as 1 over that base to the positive n power. Vice versa, if you have that negative exponent in the denominator, this becomes equal to that base to the positive n power, and that is in the numerator. You can think about this as over 1. We don't write that if it's over 1. So that is how we make any negative exponents turn into positive. If I go back to this page before where we had 625 times h to the negative 4 power, this is also, we could also say it's 625 over h to the 4th power. We can take that negative exponent, turn it positive by putting it into the denominator. In this first example problem right here, we have x divided by x to the negative 4th power. A couple different ways we can go about doing this. This is a negative exponent, so we know that we can make this positive by putting it in the denominator. We also have this x, which is right here. X to the first times x to the 4th is going to be x to the 5th power. We could also use the quotient rule and do x to the first minus negative 4, which also turns into x to the 5th power. 5 squared divided by 5 to the negative 3rd, we could subtract here to get 5 to the 5th power. We could also rewrite this as 5 squared times 5 to the 3rd power, still giving us 5 to the 5th power. M to the negative 3rd divided by m to the negative 7th. Again, we can make this positive by putting this into the denominator, m to the 3rd. We can make this one positive by putting it into the numerator, m to the 7th. M to the 7 minus 3 is m to the 4th power. Second way of doing it, we could also take m to the negative 3rd minus negative 7, still going to give us m to the 4th power. Y to the negative 7th minus 5 power gives me y to the negative 12th power, which we know is 1 over y to the 12th power. Anything to the 0 power is 1. And then we have 3x to the negative 1st power, b to the 3rd. We are going to take this negative exponent and bring it to the numerator, so my answer here is x over 3b to the 3rd power. What we have here is x to the 4th to the 2nd power, which is x to the 8th, y to the 5th to the 2nd power, which is y to the 10th. We also have this in the denominator, which is a negative exponent, so we can move this up to the numerator and make that exponent positive. So now we have x to the 8th, y to the 10th, x squared, y squared. Combining that, we have x to the 10th, y to the 12th. On the next one, we have g to the 5th, h to the 0, which is going to be 1, divided by g to the negative 3rd. Because this is negative, we can move this up to the numerator by making that exponent positive. So we have g to the 5th times g to the 3rd, which is g to the 8th. Okay, everything in this numerator is to the 3rd power. 5 to the 3rd power is 125. B to the negative 1st power to the 3rd power is b to the negative 3rd, and then we have c to the 3rd power. All divided by c to the 2nd to the 5th, which is c to the 10th power. We are going to take this negative exponent right here, bring it down to the denominator and make it positive. So that's going to be 125 c to the 3rd power divided by b to the 3rd power c to the 10th power. We can still simplify this right here. C to the 3 minus 10, so now we have 125 c to the negative 7th power divided by b to the 3rd. To make this positive, we are going to bring this down to the bottom. That gives us 125 over c to the 7th, b to the 3rd. Everything in this parentheses right here is to the 0 power, which means the answer is 1. Okay, the first thing that I'm going to do is I'm going to take all of this to the negative 1st power. So I have a to the negative 4th, b to the negative 2nd, divided by a to the negative 2nd, b to the negative 4th. From here, everything is a negative exponent. So instead of dealing with negatives, I'm going to turn everything positive. I'm going to take a to the negative 2nd and bring this to the numerator. I am going to take a to the negative 4th and bring this to the denominator. I'm going to take b to the negative 4th and move this to the numerator. And I'm going to take b to the negative 2nd and move this to the denominator. From here, I have a to the 2nd divided by a to the 4th. That's a to the 2 minus 4, or negative 2. b to the 4 minus 2 is b squared. One more step to make this positive, bring this back down to the denominator. I'm going to move up here. So this becomes b to the 2nd divided by a to the 2nd. The first thing that I'm going to do here is I'm going to take all of this to the 2nd power and expand that out. 4 to the 2nd power is 16, x squared, y squared. I still have z to the negative 3rd divided by x to the negative 3rd, y to the 4th, z to the 5th. Next thing I'm going to do is I'm going to take my negative exponents and move them to make them positive. So this x to the 3rd is going to go up here. This z to the negative 3rd is going to go down here. Now I have 16x squared. Brought my x to the 3rd up. I have y squared divided by y to the 4th, z to the 5th, and then I brought my z to the 3rd down. Now I am going to combine x squared and x to the 3rd. So I have 16 x to the 5th, y squared. I'm also down here going to combine my z's. So this is y to the 4th, and then I have z to the 8th power. All I have left to simplify here is the y's. Y to the 2 minus 4 is y to the negative 2nd power. 16x to the 5th y to the negative 2nd power divided by z to the 8th. Bring this back down here, and my final answer is 16x to the 5th divided by y squared z to the 8th. I am going to bring this entire thing down because it is a negative exponent, and I am going to bring a to the negative 5th up to the numerator. So we have a to the 5th divided by negative 3 ab to the 4th squared, b to the 5th. Expand that out, and I have my a to the 5th divided by negative 3 squared is 9, a squared is a to the 2nd power, b to the 4th to the 2nd power is b to the 8th, and b to the 5th. Combine these here and here. Can I do that at once? A to the 5 minus 2 is a to the 3rd power divided by 9b to the 13th power.